Greetings and welcome, friends. Mr. Waddy and my geometricians are here. We're talking about surface area and volumes of cones. Actually, guys, I'm on the wrong thing. We start with volumes, I think, don't we? No, we start with surface area. Whatever. So here we are. This is called a right circular cone. It says recall. This is assuming that you've seen this figure in 8th grade, probably before, perhaps. And it says a right circular cone or cone has a circular base. What do you know? Circular base. And a vertex that is not in the same plane as the base. The only new thing for us is this idea of slant height. Slant height would be the distance from the vertex traveling along the edge of the cone to any point on the circular base's edge. And height would be right from the vertex perpendicular to the plane that the base is on. This side surface would be referred to as the lateral surface. If I say lateral area, I would be referring to everything except the base. And yeah, we've got some interesting stuff here regarding surface area. Let me let's see. Before we get too far, let's just talk about surface area real quick. If I have a cube, sad-looking cube, we've talked about the idea that you could unfold the sides and represent that cube in a net. Actually, that's a problem. Is there a way that I could draw this net without picking up my pen and without touching any vertex? Having to, yeah. Anyways, so if I want the surface area of a cube, right, the volume of a cube is just side length cubed, but the surface area of a cube is going to be the area of one of those sides, and then I'm going to multiply by the number of faces, right? 6 times side squared. Let's think about this real quick. How could I draw the net of a cylinder? The net of a cylinder. Well, it's going to have 2 circles. The lateral area here is going to be a rectangle. And I'm going to draw it this way. Okay. Now let's actually label some dimensions here. So if this is the radius right here, this is the height. The radius you guys can see here, right? Radius. This dimension would be what? The height, not to scale. Question, what would this dimension be? Oh, you mean the diameter of the circle? Right, this must be the length that would wrap around the circle exactly once. So this would be the circumference, or 2 pi r, or pi times diameter. All right, that's interesting. Right, so actually, yeah, if I want the volume of a cylinder, right, we would do pi r squared times height. And the surface area of a cylinder would be 2 pi r squared. There's 2 circles there. And then I have to add the area of this, right? And that lateral area is going to be 2 pi r, the circumference. It's a rectangle multiplied by the height. So this would be the surface area of a cylinder, right? So yeah, I'm definitely giving you more than you had space for, so sorry. Let's see, real quick, let's just see if I can talk about a pyramid for a moment. All right. So we know that the volume of a pyramid is 1/3 the base times the height, right? Whatever that base would be. What would the net of a pyramid look like? Actually, let's have in somewhere, if you have space anywhere on your packet, draw for me a net of a pyramid. I'll walk around. Check it out. And Try to draw the net of the. That's an. Yes. All right, so the classic one was this spiky flower. Right? I also saw some like this where if you unwrap. Whoa, settle down, Lauren. Settle down. Don't worry. It'll be fine. Right? If you unwrap the lateral area first and then just attach a square to the side of it somewhere. Right? Actually, in terms of the dimensions of this, if this is S and this is the height, so this is an S by S square. Question, what are the dimensions of one of these triangles? It's S, and then what's this? It's the distance along this, right? And that is longer or shorter than the height of the pyramid. Longer, this is called the slant height, with kind of like a cursive L, the slant height. And I just want to point out, if I know the height, how could I find the slant height? I don't think that has a name. That's just an edge. I don't know. Maybe there's a name for it, but I haven't named it. It's nameless to me. It's dead to me, in fact. This is a right triangle on the interior of this, made up between the height. All right, let's actually draw this triangle here. Okay, there would be a relationship. All right, Aiden, that's enough. We would have the height. We would have the slant height, L. And then what's the base of this right triangle equal to? Half the side length. Yeah. Right, half the side length right there. And so you could find the slant height, or if you know the slant height and you want to find the height, you could go back and forth between those two using Pythagorean theorem. Now, if this is not a square, good luck. You'd have to do some more trigonometry from there. So this is the slant height, is that distance here. And then here's that nameless edge right there, which is weird. Question, comment, observation? Just stretching? I recommend stretching sometimes. Did you know that naps are free? Stretching is free? It's pretty great. I love it. Question. All right. For a cylinder, or sorry, a cone, my bad, a right cone, that was the surface area of a cylinder. Could someone draw for me a net of a cone? Well, or try. Yeah, do you already have the drawing? You already have the drawing. Excellent. Yeah, you're right. You guys already have it. But I think this is an interesting thing here. They talk about like kind of like arc length and all of that. They verify the area of this sector using our earlier skills. But I just want to point out that in terms of this would be the base, right? We've seen the base before. It's a circle. But then Pac-Man is the lateral area. And this Pac-Man is actually, it could be like an acute Pac-Man. Or I don't know, is that obtuse? Like when he just breaks his jaw, he dislocates it to swallow more ghosts. It also could be like a terribly skinny-jawed Pac-Man when his mouth is like almost closed. Well, it can't be a full circle because imagine like making a birthday hat out of cardboard. If I make this edge wrap around and glue it to that edge, it will make a conical shape. All right, so this edge is the slant height. Okay, so this edge is the slant height each time. And the distance around, I want this arc to be exactly the same as the circumference of that circle. So that's why this arc is 2 pi r. Okay, so the distance around that arc is 2 pi r. It's right, this bigger circle, or arc actually, it's not a full circle, needs to fit exactly around the base circle. And it turns out that if you solve for the area of this sector, right, area of the sector over pi times L squared, if it was a full circle, right, the area of the whole circle would equal 2 pi r. Where's 2 pi r coming from? That's the area of... Oh, they're working in radians? Guys, they're working in what? Wait a minute, radians? Oh, 2 pi r... Oh, right. We know the, sorry. We know that this is 2 pi r because, like I said, it's got to wrap around the smaller circle. So this was known to us. And then the smaller one, I didn't yet know. 2 pi L, L would be is the radius of this bigger circle. 2 pi L would be the circumference if it was a full circle, and I want to have the proportion set up between those two. And proportionally, the area when I solve ends up equaling Pyral. All right, so pi r L and pi r squared, we end up getting the surface area of a cone being pi r squared plus pi r L. All right. So we've had a bunch of conversation about surface area here. All right, but pi r squared plus pi r L is what that ends up equaling. And let me show you this cool little here we go, little trick here. All right, pi r squared plus pi r L. Watch this. I actually like this. Here we go. Let's unfold it. Whoop. Oh, tip the hat to you there, and then watch. Slice it. Right. I like that animation. All right, and now, guys, what I want to point out is the shorter the height, the more Pac-Man that becomes. Now it's a person. We made a person. And actually, all right. Actually, that's an interesting question, Aiden. I'm going to have you do. Come back tomorrow and tell me how high does a cone have to be with respect to its radius in order to be a semicircle for its lateral area. And then if it's a stumpy cone, that's when you'll get more of a Pac-Man shape from it. All right. So anyways, that's a nice little animation that we've got right here from... Oh, wait, I didn't know it animated. Right, and you can change the original radius. Here we go. Slice it. Unroll it. So anyways, that's good stuff. I'm signing here. Here we are. All right. So I've talked a lot about this. You guys actually know all this stuff. Tell you what, I'm going to just show you the volume formula, and I might have no examples today, but I'm fine with that. You're not? All right. So guys, we already know that the volume of a pyramid is 1/3 the base times the height. And if you imagine a pyramid that has more and more sides on the polygon of its base until it approaches infinity. The area of that base would equal pi r squared, but the volume formula would have remained the same. So the area of the base would end up equaling pi r squared. So the volume of a cone is very much like the volume of a pyramid. And it just ends up being the following. Let's see. Right? 1/3 pi r squared times height. And actually, yeah, all of these examples are near identical to ones we've done before. I'm going to let you guys start your quest right now, and have a great day, internet friends.